Well, hi, good morning, and welcome to my shop for what might be the last day with this radio. What's left to do on it? Two basic things. One is to complete the alignment. So far, the alignment of this radio has proven to be very, very good, which is quite unusual. And the other thing is the testing of the vacuum tubes. I have heard some distortion in the sound, and I suspect it's coming from a weak tube. But the very first thing I'm going to do is I'm going to replace this Herculean effort undertaken by the owner to tape these two wires that feed the light bulbs here. Wow. Well, I'm going to replace it with just some pretty ordinary looking wire, just this stuff here. That was job number one. Okay, got the wire installed. It took a little longer than I expected, but for such a simple thing. So the owner put a lot of effort into insulating these wires, and that was a really good idea, in fact, because if you develop a short on these wires, then what will happen is the light won't come on, and that's about all you're going to notice. And you're going to notice, you don't even notice when the light doesn't come on. You think the bulb is burned out or something. Meanwhile, there's a short circuit on the big power transformer, and putting this thing at risk. In the long run, this would overheat and probably get damaged in the process, and then that's it for the radio. Once this guy is blowing up, wow, the economics of trying to fix one of these becomes really bad, really, really bad. So, the owner was doing the best he could with the resources at hand. So, even though what he's done is now in my garbage can, unfortunately. Okay, enough talk about a couple of wires. Next thing, what was something interesting I was going to talk about? Oh yes, the alignment. What makes the alignment interesting? So the alignment is the internal factory adjustments that are done right at the end of the assembly line by a technician with some test equipment, and that tunes up the radio and compensates for all the variations that occur in each individual radio as it's built in the factory. Those adjustments are normally done once in the life of the radio, because the life of the radio is normally 10, 12 years, maybe longer for something like this. But then that's the end of it, and there's never a need to go back and do an alignment unless this radio turns out to be hanging around 60 years later. Then it almost certainly requires an alignment. But in the case of this radio, so far I've discovered the IF cans are aligned just fine, right on frequency. It's quite surprising, in fact. Very surprising. But I don't have any instructions to do the rest of the alignment, so I'm going to have to just figure this out. I don't think it's too complicated for this radio. It's a 3-band radio, so there's going to be 3 sets of things to work on. One of them is for the broadcast band. That one often has a little more to it than the short wave. So if we look down in here, you can see these beautiful brass colored things coming up here. So these are actually adjustments. This is a type of capacitor here, and you pull this plunger up and down to change the capacitance. Then way down below there, wow, you know what? It looks like the locking nut is missing on every one of these. I believe the nut that you can see down there is just holding this in place, but there should be another nut that clamps it, and I think the clamping nut is missing on all of them. Okay, that's a complication. Not there. Look at how high up this one is compared to the next one over. And this one over here is way up high compared to the others. Sometimes that means something. Okay, so that's what we're going to be adjusting. There's 6 of them there, and there's 2 bands. So probably there's 3 bands, so probably 2 per band. If you take a wild guess that they're arranged like this. So these 2, and then these 2, and then these 2 here. But that's a guess. There's no reason why they have to be lined up in some kind of sensible order. The capacitors have no capacity. The tuning capacitor has no trimmer capacitors of its own. So, but there is one more back here on the back apron, right there. Another adjustment that has to be made right there. Saw that in the documentation, or I would have missed this probably. Now, if you look at the capacitor here, you see both sections are the same. They're the same size. So, in order to make this work properly, there needs to be a series capacitance with the oscillator side, of local oscillator side, and that's what this is back here. This is the series trimmer, and these are all, I guess, parallel guys in various ways. I'm drifting off. So somehow I got to come to grips with which band is which one of these. And one way is to operate the radio, select a certain band, start moving these and see which ones are sensitive. In a radio that's way out of alignment, then that would be okay. But this radio appears to be in alignment so far. If I start just yanking these around to see what's what, I will knock everything out of alignment, and maybe not be doing any beneficial steps at all. I mean, how bad is the alignment? I think there is more information in the documentation on these, come to think of it. Let's take a look at the documentation and see what we see. Okay, so this is about all we've got here. I'm going to zoom in on the lower right corner. Here. So here's the capacitor we were just looking at. Here's the adjustments. Different frequencies are listed. Oh, there is a pattern to them here, a very distinct pattern. They are kind of, geometrically organized. Can I say that? And then here's the note: 600 kilocycle series trimmer on rear apron of chassis. So what we know now is that if we do the 600, the low frequency end of the AM tuning, and we do the high frequency end with this guy and this guy. So why don't we attend to that now? There's an order to these things, and getting them out of order might cause me to enter into an endless circle of adjustment. So hopefully that won't happen. I think we should do the broadcast band. Well, most of these radios, they start with the shortwave band. And the fact that it's got 5 kilocycles here is a little bit surprising to me. It's got the high and the low. The high and the low. Oh no, it's not surprising. It's a 3-band radio. I keep getting it in my head there's only 2 bands. 3 bands, these are probably center of the bands. This is probably center, this is probably center. This will be the high end, obviously, of a broadcast band, I think. Okay. Well, I think I could probably pull this off without too much trouble. One of these is for the local oscillator, and the other is for the antenna circuit. Right, the antenna circuit. Okay, I think I'm ready. Okay, I've probably taken on too much here at once, but let's try a few things. First of all, I want to use this meter, and I want to use it on AC, and I have no experience with this meter on AC other than a single initial test. I think this is the AC probe here, this rather stunning looking thing. Okay, so I think that's the probe, and the connection point is right here. When I connect them up, we should be sending AC, the input to the volume control, the alternating current signal, audio signal in fact, over to this meter. The thing about this meter is it's very sensitive. I can get right down to 1 volt full scale, which is helpful in doing this work. The other thing is, on the screen you see my SDR up in the top left hand corner here. So that's tuned right now to 17.640 megahertz. So the idea here is, if I tune this radio to 17 megahertz, which I've done on the front dial here, it's right over here at 17 megahertz, then the local oscillator should be running 460 kilohertz away from that, either above it or below it. We don't know whether it's above or below, or where it should be, above or below. I don't have the information. I haven't encountered the information to know that for sure. There's a way to figure it out, but there's also we can make the assumption that the radio was aligned correctly in the factory, and it still is correct. Even if it's a little bit out, it's not reversed around. This has to do with the difficulty of aligning these radios with the large frequency range here on shortwave without accidentally aligning it to the image. And I won't go into that in detail. You can look that stuff up on Google if you want. You look for image rejection tube radio or something like that. That'll get you something to read about images, image rejection, and the difficulties in doing an alignment like this. With usually the instructions contain something to tell you or something to guide you around this problem of whether the local oscillator should be above the target frequency or below. So when I turn the radio on, back up this coil here I am now holding, this tangled up coil here. This is going to pick up the radio signal being produced by the radio, the local oscillator, and it's going to be show up on the SDR screen here. And that's how we're going to do the alignment for this radio. Had this kind of equipment been, something like this, like the SDR, something like this, I don't know what could possibly be like this, within the range of an ordinary repair guy's wallet, then this is the way alignments would be done. But this kind of equipment didn't exist. You couldn't, you couldn't whip out your computer and do this kind of stuff back in the day. So I have a great advantage here. Now I'm going to put the pickup coil somewhere near the tuning capacitor here, and I want it in a kind of a stable arrangement so it doesn't move around while I'm doing this. Because I want to put it somewhere where I'm not going to bang it, or even where I could kind of clip it or stick it, or how about like that. Okay, it's not the best, but that'll do. It'll stay in place if I swing this a little bit. Okay, and is it in the right spot to pick it up? Well, we don't know yet. We're going to turn it on. We're going to find out. Find out about this. Find out about that meter. And there we go. So so this should come up at 1760 on the SDR right above my finger. You can see the red line. That's set at 17460. That's why I can't point to it. You can, if you read across, you'll see the number over there, 17460, which is the tuning point of the SDR. Enough talk. Let's turn it on. Is everything okay? Just double checking. Yes, we're going to need this eventually. I'll start warming it up too. Okay. I think we're ready. Here we go. Watching the SDR. Watching everything. Not the meter. Meter's not connected. Watch the SDR for something to come popping up. Something to come popping up. Bit of a different camera angle here for me, so I'm figuring out the ins and outs of it. I didn't see anything pop up. Anything pop up? Nothing popped up. Well, interestingly enough, so if you hear that tone, that's really going to be handy. I just happen to have left my signal generator on 460, which is the IF, and it just so happens to be coming through the radio. We can hear it. Now that's going to be handy for checking this. Let's check this right now. I'm going to hook up the meter. And then we're going to tune something. I'll tune this guy. See, I step right in front of the meter when I do that. Camera angles. Can't get them all. Okay, I'll just have to do it on my own. Yes, the meter is reacting. Very good. But on the 1 volt scale, there's hardly any reading here. So even with this meter. Okay, we need to go full supply voltage here. Okay, now what's on the, so nothing is showing up on the SDR, nothing at all. Nothing that I see. Oh, Okay, could be wrong location for the pickup coil. Let's move the coil around here. Bring it over near these tubes. Well, there's something down around 16,800. 16,800, that's just above my finger roughly here. That's a little odd. Wow, is that the thing? Put this in here. So I'll tune the radio. When I tune the radio, where did that thing go? This is a little odd. Nothing. You know what? Maybe I'm on the wrong band. Could that be the case? There we are. Why did that? No, this should not have happened. This should not have gotten louder like that. So this is broadcast. Why so faint up here? So the signal is going through the IF transformers here. I'm feeding in the IF frequency. It's going through the transformers. I would kind of imagine it would sound the same on every band. It wouldn't be that much different. It might be a little different. I'm a weakling. I wonder if, is it possible the IF tuning changes when you change bands? Shouldn't happen. Let's experiment a little bit here. I'm going to adjust the IF, but I'm going to return it to where it comes from. We're just going to see, does this get any louder if I do this? Not like that. Let's try. Just bear with me a second here. We're going to pick a more appropriate tool. I wouldn't say so. The risk in me doing this, well, first of all, there's only two adjustments. The other two are underneath. I gotta get underneath to do them. We're just experimenting here to find out if this is okay. Does it get louder? Barely changes. Can't tell. I don't think it's likely the IF changes tuning when you change bands. What else could be happening? Oh, I know what's happening. I'm feeding the IF signal in through the antenna. So as I'm switching this, I'm switching all kinds of coils in the antenna circuit. Now that's all that's happening there, I'm pretty sure. I think I'm chasing smoke here. Where the middle one was louder. Ooh. Dirt in the switch. Okay, so we'll assume that's the case. And it really doesn't matter what's going on here anyway. How come this is looking like that? Wow. Just 1 second, I'm just doing a quick calibration on this meter, on this guy. Okay. Now let's get back to what we're really trying to do here, which is where's the local oscillator? Where's that local oscillator? So again, we're right on 17 here on the red band. But I don't see any local oscillator at all. Let's put this back in here, that might help. Usually the local oscillator will show up as a very tall very tall guy. We don't need to listen to this anymore, so we're going to go way up into the band. Yeah, let's send a 17 megahertz signal over and see if the radio responds to it, and maybe I'll find out I'm really not on the band I think I'm on, or even more. Okay, 17. So we're going right through 17. Not hearing a thing. There's a very strong signal sent now from the signal generator to the radio. Well, I got something really messed up here. Something's really messed up. This, I believe, would be tuned to around 5 megahertz now. Not 17. 5, eh? Ooh, okay, just look by there with a very, very strong signal. Let's go back. 5200, and it's dialed in right now at, exactly 5200. That's amazing. Okay, so this is definitely this band. Okay, go back up. This is definitely the shortwave band, the high shortwave band. Let's tune the radio down to, let's go for 10. This is 10 megahertz right here. Okay, making sure the parallax error is minimal. Meter has, there must be a vacuum tube in here. It's warming up. That's why it's so large. Very similar to this guy. This is my signal tracer. There's a vacuum tube inside here to give a very, very, very high impedance. This is typically not done with AC. This is done with DC. I don't know what I'm doing with this meter. Okay, that aside, that little problem aside, where are you, local oscillator? Also very weak. Wait a minute. Yeah, I definitely have too many things on the go at once here. That's perfect like that. Now, oh, I see a big signal on there. Okay, so I'm on the high band and tuned into 10. We should be getting a signal, a local oscillator signal around 10.4. This is 17. It's almost like double what it should be. Let's go down to around 10. There's another big signal there. So the radio has harmonics in its local oscillator. So now we're down around 10. And here it is, right here. I think this will be it right here. That's at 10.845 when it should be. Again, we have the above and below problem. That should be 10.460. Okay, so we can take action here. You can align the radio anywhere you want. Now, I've got a tool that I use for this. For these kinds of adjustments, I use this hook, because in that shaft that I showed you earlier that's sticking up, these guys down here, they have a hole near the top. So you can stick this in the hole, and then you need to rotate these things. It doesn't go in the hole very well. You need to rotate them while you pull them up and down, and it's a two-handed job. You got to hold on to the radio and everything. These are really awkward adjustments, which are only meant to be done in the factory when they're nice and new and clean and everything is wonderful. They're not really meant to be done now. So which one is which now? I'm on the shortwave band, which I believe were these top ones, and I'm going to identify which of the two capacitor halves are the local oscillator by interfering with them and watching that oscillation move. I'm watching nothing's moving. I'm watching the SDR. Touching the wrong plates, Jen. See, it doesn't retune. What about over here? There, see it retune? So that's the oscillator, local oscillator control. That's the one that we want to adjust. Why did I need to know that? I don't know. I don't know. Now we're going to try to figure out which. So, oh, I know why. Because almost certainly this set back here goes with that capacitor section. So this would be the guy who's pulled way up here I was talking about. Let's see if I can move it downwards. This tool is not working here. It's the holes are too small. I have a vast array of alignment tools, so I'm going to look and see if I actually have. Yeah, really, I literally have a vast array of tools here. Let's see. Yeah, well, I've got everything under the sun, so I'm looking for something kind of unusual. Wow. Looking for something that would has some kind of a hook on the end of it or something. I don't see anything in here. It has a hook on the end. Boy, oh boy. Well, let's look in this one. Leather bound. Anybody with this weird hook thing? There is such a tool. Well, I don't see anything that looks like it would do the trick here. Hold on, this isn't the end of them. I have more. Yeah. Down here. And I do have a weird one with a funny metal protrusion. Am I going to be able to find it in there even? This is bad news. No. Well, could just try to grab them boldly with a pair of pliers. I'm pretty sure this hook thing is not at all the correct thing anyway, because I do have a memory of what it looks like. We're back to this thing, or something like this. Yeah, the other radios I've done with this kind of capacitor, I've been able to move them pretty easily. It hasn't taken that much effort. See, this isn't going in. It must be the hole is smaller on it. Or am I wrong, and these are the locking nuts here? They don't look like it. They don't look like it. The locking nut is a much larger piece. Well, I wasn't expecting this problem. How do we know that any of these have to be adjusted? How do I mean, all indications are this radio is well aligned. I haven't found anything yet that says, yes I have, I just found the local oscillator way out. What am I talking about? I can stick my hand in there and just grab it to get a feel for it, but that's a little difficult. Grab it with a big pair of pliers. And in fact, I've got the parallel pliers. So these guys, these are pretty old. Notice the jaws, when they open, they remain parallel. Right? They're not doing the scissor thing. And that's a mean cutter there, boy. There's like a gearing, a leverage in here that's very, very powerful. It's a big hunkin' tool. Yeah. Can you use metal tools? What about a 50-pound metal tool? Maybe just to break these things loose and get them moving. Oh boy, that's as solid as can be. It's slipping on the tool. Wow. Okay, let's go down. There's almost no room here. Just try another one. it's just slipping around it. My gosh. Isn't this another fix I've got myself into? No, I didn't get myself into this. Can I turn any one of these? No, this tool is just camming out. It's just getting no grip there at all. What do you do about this? I don't think I want to shoot lubricant on there. I can't imagine those nuts are the lock nuts. They're not shaped right. Those nuts are just holding that stuff there. Oh my gosh, and look at this the last adjustment. It's right up against this wall too. You can hardly get anything on there. Oh, this one turns. Don't do it. That one moves. That one moves freely. Okay, I got one to move. Now I've restored my... I gotta come up with some other tool or something. I gotta come up with something here. This isn't working out. Not working out. The situation here is I'm kind of stuck until I solve the problem of getting those guys to move. There's not much more I can do. So I'm going to attend to other things in my life here, and hopefully I will stumble across some idea or tool, or I'll make something in the end. I can get down and grab those guys and twist them and the like. I was really kind of counting on this. Maybe I need to grind this down. That's not a bad idea, you know. Just grind this down. Yeah, that's a possibility. Okay, so I don't know what I'm going to do. I may not get back in here today. And just like that, it's the next day. That's right, I never got back in my shop. But I did spend time out in my garage trying to file this guy down and make the tip small enough to go into the hole there. While I was out filing away, realizing that this is probably not going to work, I began thinking about what have I got? What have I got that's shaped like this that's going to do it? And voila, the Allen key. Yes, I have an Allen key, and guess what? I can fit it into these guys here like this, and then you can actually turn these. Now, turning them in itself isn't enough. You have to pull them up and down, but the only way to get them up and down is to have them rotating, so you're kind of rotating them up and down. So I've got the tool. I've managed to turn them all a little bit, except one is very, very stiff. They're all stiff, but one is very, very stiff. So we're ready to go. That's the great news. And you know, the Allen key is very, very stiff metal. You know, so you can put a lot of force on one of these guys. That's great. And I even managed to file this down enough that if things are loose enough, I can use one of these. I can use this, which is much better because I got a great grip on it instead of a little tiny fingertip grip. Okay, so we're going to warm up this radio, warm up some more equipment in here, and we'll continue on with the alignment. That's kind of what we got to do here. That sounds great. You're just muttering, Jim. What are you talking about? I don't know what I'm talking about. That should be fairly apparent to most people. Now I have did an interesting experiment in here. Maybe I can replicate that today too. Okay, great. I'm just going to let everything warm up for a few minutes here, and then we'll get going. Okay, I think I'm ready here. Now, if we look at the SDR is tuned right on top of the local oscillator peak. I'll just move this over. See the peak right there. But this was after fooling around, and I ended up on the wrong band here, I think. So let me turn the band switch. So this is the broadcast band. I could only hear something that would prove that. Where did I see instructions on which band is which? Where did I see that? Just to be absolutely sure. I don't know. Okay, we'll have to figure it out directly, just to be sure. So I believe right now I am on the high frequency shortwave band. And the pointer is tuned to, let's tune it right on 10. Okay. So now there's a local oscillator active right around 10. This is right around 10. Did I say 5 before? Where did my head go? Oh, I know what it is. It's this number. I got that number in my head. We'll ignore that number. So we're tuned to exactly 10. The local oscillator should be at 10. I'm going to move this over. Should be at 10, 460. 10, 4. I'll set the red line right on the 460. That's where it should be, not over here. So the first task is to try to move that. Okay. To move that over, and this has nothing to do with what we're looking at on the screen right now. I'm going to grab. Oh! I don't have the meter connected over here. Yes, I was experimenting last night, and as I mentioned earlier, I may show you what I was doing. This is the audio input to the volume control. I'm looking up here. Okay, so this isn't even important right now, Jim. That's okay. It needs to warm up anyway. Okay, so ignoring that, ignore it all. It's just what's happening on the SDR. And it was AM, middle shortwave, high shortwave. I believe this is the oscillator here. So what I'm going to do is, you don't need to look at that stuff. You can actually it's a little hard to see what I'm up to because it's hidden behind the. There we go. Let me try with the big one first, because if I can make it work with this, it's better. And this one I think was pretty loose. Okay, first I want to prove I'm on the right thing. So we're looking at the SDR and seeing if the local oscillator moves. And it is moving. Oh, it's coffee break time already. Look at this, is pulled way, way up. I think I can get it all the way to the red line there. Holy smokes. So you got to wonder what happened here that this got all the way up. I'm going to get hurt doing this. I just know it. Just more to go. Wow. I was telling my wife yesterday that accidents require 4 key components. And I told her I can't remember 3 of them. But one of them is energy. Energy can be in almost any form. One of them is pushing hard. Push hard, you have a pile of potential energy stored up for the accident. Oh my gosh, that's just unbelievably hard to push down. Whoa, 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 whoa. Getting close. Notice it's getting down to almost the same height now as the others. How did it get up this high? Okay, we're getting close now. So what's the crackling? Must be some dirt in the capacitor. Let me just about made it. Not much left here. That's it. I think we've hit the bottom of the run. Well, we got right up next to it. That's pretty good. The effect of this is twofold mainly. It makes the pointer accurate on the radio, or controls the accuracy of the pointer. And also, there are other circuits that are aligned, and you need all these things lined up. So I've just moved the local oscillator. It's possible the rest of what I've done really is I've brought the local oscillator into the rest of the radio's alignment. Am I clear? I'm not being clear at all, am I? So that's a big change. Now the next thing is to peak up a signal. They say do it at 17. We'll go up. Maybe not all the way to 17. This is nice and easy to tune to a dial now. Let's go to 16. 16 is marked very clearly. Okay, radio's tuned to 16. So if we send over a 16 here, we should hear it. Oh, that's right on close. We have a weak signal. Oh, that's not very good at all. So that's what we got. Now, if you look on the SDR, just turn this down. If you look on the SDR, this isn't that critical anyway, because the owner has told me he's not terribly interested in shortwave. But let's make it at least reasonable, because he may get an interest. So here you see the local oscillator out here. So the radio is actually tuned. I'm checking again to be absolutely sure. 16. That is 16, isn't it? Yes, 16, not 15. 16. So with it tuned to 16 megahertz, that would be here. The local oscillator should be at 16,460. Let me set the. So it should be way over here. That's the size here is almost the width of the shortwave band, which means this radio would have trouble tuning much of this shortwave band. It's going to be, that's baloney. What I'm saying is baloney. What I should do is this. I will set this to here. So now the radio is actually going to receive 16 megahertz. But what does it say? What does the radio say? Ooh, a bit of a rough ride there. So it says 16.4, I would say 16.5 instead of 16. That's not that bad, really. I mean, again, I'm not going to dwell too much on this. So we'll accept the local oscillator where it is. We'll pick a nice frequency. Most of the listening anyway on shortwave would be done in the evenings down in this area. So I'm going to go back to 10. Down in this area actually is where you'd be listening. You see the markings here? 49 meters, 31 meters, 25 meters, 18 meters, and I can't read that one. 16? 19. That should be 19 meters, and this, I don't know what that is. Way up there. Most of the listening be done down in this area anyway. So let's set up on 10. The next stage now affects the sensitivity of the radio. 10. Oop, volume's turned down. So there's a heterodyne in there. There's the lower tone that's coming from here. And then there's another tone, the heterodyne there. I'm guessing that's from WWV. I don't know. I think that's a bad guess. Okay, so what we want to do is make this stronger. Let's do it this way first. So I can hear it clearly, sort of clearly. And now we want to adjust there it is. Come on over here. Take a shot at adjusting the antenna adjustment here. Don't I have a meter hooked up? I need a meter hooked up at this point. Need a meter. Let's use this meter. I turn this one on. It's all ready to go. Hello. Jim, you've already got it connected. Come on, man. Get with it. Let's check now with the volume. No, I don't have it right. I have something wrong there. Something is wrong. Something is not right. AC. It's up just a bit. Take this off. Or it doesn't go to 0. Hey, what's happened here? Our scheme is... What am I doing wrong? I'm doing something wrong. There. Okay, let me try this here. Take this off completely. Whoa. Something's amiss here. Something has gone haywire. Completely haywire. What has happened? Oh, I don't know what to say here. I gotta stop and drink some coffee. Maybe that would fix it up. That's right. That's right. The volume doesn't affect this. This input's not affected there. It's affected over here. Okay. Okay. So what happens if I just boost this? There we go. You see the meter move. Okay. It's not much movement in here, unfortunately. But we'll have to work with that. Okay. In fact, I'm going to jack this up a little bit here. Okay, we can do this. We can do this. Now, make sure that the radio is tuned, or the signal generator is tuned exactly to the radio to do this. So I'm going to move this around. Oh, it's just a hair trigger. Okay, that's at the top. Now, find the tool, grab the right adjustment, which would be this one. Okay, I'm trying to watch the meter now. Incidentally, I don't know what, never mind. Okay, never mind. There it goes. See it going down? Okay, back the other way. Going down a bit. So it was pretty much in the right spot. Right in there. Okay, there we are. Alignment of the shortwave band. Now we'll go to the next band. This band. It's the green one here. We're not going to hear much on this at all. Ever. So we'll stick it to 3 megahertz. We'll do everything right at 3 in the middle of the band. 3 megahertz. Let's check for how sensitive the radio is. Wow, it's bang on. It's bang on 3. That's kind of surprising. Let's just do a little fine tuning here. So we're on 3 megahertz here. Look at the signal generators. 3 megahertz. Wow. Okay, so we'll skip the local oscillator and we'll adjust just the middle, just the antenna. So I want to watch this. Okay, thinking about which one to move. Moving the right one. Okay, here we go. Going down first. Some of these move pretty easily. I'm going to use this because I'm just so worried about that other tool slipping out. This is very stiff. Oh, I don't think I'm going to be able to move it. Unless you can move it fairly quickly. I mean, it's hard to tell what's happening on the meter there. Okay, lifting up. Going down. The meter's going down. Okay, going down. Oh, I think I end up with skinned knuckles here for sure. Going down. It's going up. Looks like it stopped right there. Going up. Okay, that's not bad. Now we're down to the real band in question. Broadcast band. Broadcast band has 2 oscillator adjustments. One for the high end, one for the low end. The low end one is on the back apron of the radio. The high end one is just one of these again. So we're going to go to the high end of the band. Tune to 1500. We'll pick 1500. Okay, I'm making sure it's right on 1500. There we are. Now we're going to tune the signal generator to match. Let's see. This is up a little loud. Let's turn it down. 1500. Just about dead on again. Amazing. Huh. Well, you can't get much closer than that. Okay, so but if we look at the, so that's the oscillator adjustment. It's dead on. There's nothing to change here. Not at 1500 anyway. Oh, let's go to the other end because it's right. There's a low end adjustment. Okay, so I'm going to tune the radio way down and do it at 600. That's a typical spot. This is where the stations are anyway, down at this end. Okay, 600, eh? Really? Really close. just a wee bit out. Okay, so we'll set this to 600. And we're going to keep our eye on the meter there. I'm going to adjust this back apron adjustment. It's right here. It's right back here. Right in here. Okay, I'm set to go. This means the radio will tune 600 when the dial, when it says 600, it'll be 600. And we should go up to the top end again, but I'm not going to because the fact is I can't do much more with the adjustment up here anyway. And the other end, the high end, no one's going to be listening up there. There's nothing up there. So it's all about this 590, 640, 610, 680, 710, 740. And 860, I believe, is the French station. So they're all very, very low frequency end of things. So what have we done here? So that's good. Now we want to do the antenna trimmer. So I'm tuning back up to around 15 again. Not around 15, but right on 15. Okay, I'll go up here again. 15. Oop. See, it's still very, very close. Okay, so I want to pick a better spot here, just where there's none of that noise. There we are. Okay, I'm watching the meter to make sure it's as high as it can go. A little ABC action happening here. Okay. Make that go higher. So to make that meter go higher, I'm not really using the SDR at all, are we? So, and that's okay. SDR, okay, never mind. Well, you know what? My coffee alarm went off. I ignored it. That's why I'm talking over top of myself here. So now we want to adjust this tall guy. He's sticking way up here again. See, this guy's like, anytime you look on a radio and you see a pile of adjustments and one of them is way out from the rest, like these are all down low and this one's way up high, gotta be suspicious. Doesn't mean it's wrong, but okay, so this is tight in here. I think this one's easy to move though, so I'm just going to move it. Yeah, a lot of these you can just zip up and down. There it goes. You know, what I heard the radio get quiet, is what I heard. Okay, that's what I'm going to be doing while you're watching the meter here. So I pushed it down, things got quieter. What if we push it all the way down? Oh, that was the sound of the tools sliding out. Oh, I think that meter's only going one way. It's just going down. I've got the control about halfway down, so I think it's up for a reason. So I'm going to pull it back up. As soon as I get the tool in here. There we go. Okay, come back up. Coming up. Up, 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 up. And that looks like that's going down again. Okay, back down. No, back up. You know what? That's the limit. Well, there's another thing. When you see something like that, the trimmer is at its limit. It means the capacitor has too much. Assumably pulling these out is reducing the capacitance. There's already too much in there. Now, I could do this plate bending thing. I've never done it. I've avoided it with every radio I've ever worked on. I bend out the plates, reduce the capacitance of the capacitor, bring it within the range of the trimmer. But rather than do that and run a risk, I don't like the idea of bending the capacitor plates myself, personally. Let's have a listen to this radio and see how well it's working at this point. I think that's a really good idea. So we're going to remove all the equipment, attach a proper antenna, and we're going to go through shortwave and everything, see what we can get. Okay, that's what we're going to do. Fantastic. So we're listening to a faint signal from 590 on a wire antenna. It's not even connected. It doesn't help. You can hear it faintly. The voice. Now I'm going to move the antenna adjustment, non-local oscillator adjustment. I can move this one quite rapidly now. Do you hear any difference between where it is now and here? Didn't hear anything change at all. So this is really affecting the high end of the radio. Let me pull it back up. There we go. It's not having any effect on the lower end of the band, which is not surprising. Okay, next thing. We're going to put a better antenna on here. We're going to put a loop antenna on the radio, and we're going to see what we can do with it. Well, it sounds like fun. I stop the recording before I go drink coffee. Okay, let's see how we're doing now. So 590 is the strongest AM station. We're still on just the outdoor wire antenna. So not very good. And we'll just
let's talk about the arms on the skin.
So there's a station right here, but this noise just wipes it right out. Station right around here. There's a French station right in here. So the reception on broadcast is terrible with this wire, but that's not because of the radio. It's really the antenna. So now we'll go to the shortwave band that's in green here. If we hear a voice on here, it's time to run. We shouldn't hear anything but just noise and crap. It's not even worth tuning through it. But I am. There's nothing here to hear. Okay, now we'll go to the shortwave band. That's more likely to have something on it. So now we're on the red band. And I've had to turn the radio way up. We could probably pick up a station somewhere down in this area. But in between, who knows? Let's go see. We're way up high right now, frequency-wise. I believe that would be the 16 meter band. That's probably 15,770. Not sure what that is. Nothing. There's a European shortwave band around 13 megahertz in this area. Where'd the hum come from?
But that gave me a feeling of trust, of confidence. And that's what he's talking about here. He's talking about all these things that are...
That's from the United States. That's not coming from Europe. And we're getting down around the 25 meter band. We'll pick up Cuba, probably. Lots of weak signals there. No, nothing there. No. Okay, coming up on 10. Again, this is a bad time of day. Bad. I mean, 10 is okay for this, but wrong time of day. It's 10:30 in the morning now. Okay, strong station coming.
Shame. And then verse 9 and 10. But you are a chosen
Okay, so
generation.
this gives a much better idea of how well this radio is working. Hear the hum again?
That you may proclaim the praises of him who called you out of darkness into his marvelous light.
Hum heard when the station's tuned in.
People, but are now the people of Yah, who had not obtained mercy, but now
But no hum when not tuned in.
any of us can do to either earn or deserve. All we
How about distortion? Let's just listen for distortion in his voice.
As his elect, we are granted many privileges and honors. Again, they're all gifts.
Tone.
Nothing we can do to earn or deserve it. And the greatest honor of all, of course, is yet to be bestowed.
Voice and
That
music.
comes when we are privileged to live with the Father on the earth made new. He even shares his home, the New Jerusalem,
Where'd that hum
with
go?
us. John 14, verse 2. In my Father's house are many mansions. If it were not so, I would have told you, I go to prepare a place for you. Precious promise. One thing in this verse, though, that I think underscores the true reward is the fact that the word mansions in the Greek
So there is a difference from this control.
is dwelling places. So, in other words, rooms,
Base.
bedrooms, that kind of thing. Yes, that's right. We hear
Less
the word
base.
mansions and we start thinking pound signs in our eyes and think of getting to live in
A little hard to hear with the speaker just sitting in the open, just on my bench behind the radio, right? So that's what we're listening to. Put that in a cabinet, and the bass response is going to be impressive. Okay, so back to what we were doing, which is there's going to be nothing south of here, nothing below here to here.
Yeah, that's exactly what it sounds like, yes. Again, the whole point of redemption is
Go slow here. No. So at night, late at night, 10 o'clock at night, you'll be tuning down in this area and picking stuff up. Basically, this is the half to be listening to in the evening, and during the day, this is the half to try and listen to. But anytime, day or night, in the middle here. And it all depends on conditions. So I don't think we're going to hear a thing down here. It's really not even worth hunting down there. Ooh, the radio got very quiet. So I'm going to have to compensate with a bit of volume there. Okay, now one more test. We need a couple more things. We need to put a loop antenna on here and test the broadcast band with a proper loop antenna. I think we're going to get a much better response. So we're right down around 590. Let's put it back on 590. Ooh, volume down. Wow, what's happening here? Okay. Fortunately, there's a huge amount of interference right on top of it. But we try the other antenna, things may change. Let's give the other antenna a go here. Okay, I've connected the loop antenna. Unlike the wire antenna where I just use one wire, the loop antenna you have to use 2 wires. And so they are connected there. You can see them going around the back, ground and antenna. And this is what my loop antenna looks like here. I have a big, physically large one. This thing here. Turn the radio up. Okay, I don't know where this is tuned. It's also a tuned antenna, and it's directional.
Unreliable. The things you rely on won't work when you
Tune it.
your hot water, computer, washer and dryer, electric car, TV, lights, mobile phone, stove, your heat in -30. Visit tellthefeds.ca to learn why Canada's power grid will be unreliable. And tell the feds, reliable and affordable electricity matters. A message from the government of Alberta.
It's a provincial responsibility. What is going on in my country here? I got a province that keeps pointing the finger at the federal government for things they themselves are responsible for. It's kind of weird. Okay, so there's 590. We can go a little distance now. What I meant by that was the antenna has a bit of a tuning range to it. Let's see what we can do about the ticking. With the directional antenna, we might be able to null it out. Wow, she was happy. There we go. I think that's 610. That's St. Catharines. That's very good. Picking that up here. 640. Now there's a huge noise signal right on top of it. Can we find 640 in there somewhere? You hear it?
Going into, I'm going to get into stagflation, but to segue to that, this week in,
Hey, what's that?
in fiscal deficit spending. And who wants to own a bond for 10 years knowing what if they're gonna be at 33 trillion in debt today?
Beautiful.
What's the debt level gonna be in 10 years? What's the dollar gonna be worth in 10 years? Is there
In 10 years, the dollar will be worth about half what it's worth now. So this is 680. You see, I've tuned out of the range of the antenna. So not only is the signal a little low, the noise has gone low. But now we'll pick it up here. See, we can get 710. So I'm out of the range of the antenna by quite a bit. 710, I think, would be somewhere right around this area. Can we get it? Is there a 710? I don't think there's a 710. I think I'm mistaken. It's 740. Ooh, what's that? This must be 710. It's on 722. Antenna tuning?
That's an internally stored flexibility and mobility. You'll see daily as you
Okay, we're going to zoom all the way up now to 860. Is it 860 or 840? Again, I got to tune the antenna. Catch up. Okay. So unfortunately, that interference, it's germane to my house here, my location, that tick 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 sound. Now we're going to try another loop antenna. We've seen how my antenna operates. I'm familiar with my own antenna. I've used it on so many different radios, so many different times. This guy's working quite well. There's no doubt about it. Let's try a smaller loop antenna and see how that works out. This is the loop antenna we're using now. Tuning it. Very sharp. Very good. I still hear the ticking sound. You just can't null that out. And as you can imagine, putting a loop antenna here with all these tools and equipment and down here in my basement, this just is kind of the worst place in the world to be trying to do this. Now let's go back to 590 here and see what that sounds like. 590 is kind of the one, the French signal up here and the 590 are the two that I use to judge things because I'm so familiar with them. Okay, so 590 was something like that. So there's nothing there now. I will tune the antenna, which is just sitting in a random, I don't have it aimed.
Would be the Miami Dolphins. And this is not to say that the Dolphins are a bad team. Like, the Dolphins are a great team.
when I null out the interference, I null out the signal at the same time.
Just look at the bill
So
game there.
generally,
Example, the last time Miami went to Buffalo.
generally, the antenna receives in the direction of its loop, and it doesn't do well in this direction here. So this is where you're aiming the antenna at the noise source, which certainly in my case, and I think in most people's cases, you really don't know where it's coming from. In many cases, I think it's radiating out of the house wiring in our houses, coming from some source, like maybe a small power supply somewhere, but then the signal is sent back through the hydro wires and it's all over our house. And no matter how hard you try, you can't get any sense of where it's coming from, because it's coming from everywhere at once. So there we are. Now, there's one more thing that has to be done here, and that's the alignment of the light bulbs. So the alignment of the light bulbs, it's trickier than you might think offhand. So we'll take a look here. We're looking right now. Yeah, doing this on camera is a little difficult. Yeah, that's really, I can't really show you this. So, well, I can show you the effect. You can see the effect. So inside the light bulb, if you think about it, is a filament, and the filament is like a point of light. And you want that point of light. See, this is the glass panel here. Let's say my hand is the glass panel. Okay? You want the light, the point, to be lined up exactly with the glass. So this is the light bulb here, and inside the light bulb is the point of light. And if you put it like this, it's not going to work. Not as well as it could. It needs to be lined right up. The moment it's lined up, the light rays shoot into the glass, through the glass, and then they light up the letters from inside the glass, sort of. That's, I guess, the best way I can put it. So when we look at this right now, we see kind of a hot spot over here, and it's hard to see. What if I do this? This is very difficult to do with a camera, by the way. This kind of stuff. It's really tough to do. So it looks great on camera, doesn't it? And with my own eye, it looks pretty good too. So it's a little hot here, but in fact the whole thing is lit up quite nicely. So maybe it's all baloney what I was just saying. So I'm going to move the one light over as best I can here. Oh, this is quite stiff. Maybe I can just push the bulb a little bit here. I can. So I push the bulb. What's happening to the light? Nothing good. Yeah, this is all. This, you know what? This is probably looking just fine, and I'm wasting time here. With other radios, for sure, you want this bulb. In fact, they arrange these pieces of paper so the light can only go into the edge of the glass. That's not quite the case with this radio. So it's pretty close. It's close over here, and it's very close on the other one also. And maybe that's why it's working so well. Well, it's looking so good. Let me see if I can move the light bulb here a little bit. It's just springing back to where it came from. Well, the fact is that looks great, especially on the camera. It looks fantastic. You know, can I make that any better? No, I can't really make that any better. So, but that is true what I was telling you. In some radios, it's absolutely critical. The dial goes from being kind of, sort of lit, this way, to being lit like this one, just kind of glowing there in a black space. It's fantastic. It's beautiful. After all, that's what people look at. When they look at these radios, they look at the dial face. That's the big turn on. Okay, we've reached the end of the road with this radio. It's finished. Now you've done it. You've done it again. Another radio working fairly well. I guess you can't make these guys work perfectly, but fairly well is pretty good. That's it. I have to take the bottom off to get this clip out from inside the radio, unfortunately. Let's turn the power off before I make a stupid move. And the testing of the tubes, not really needed. I mean, the radio's operating, so why would we test all those tubes? I don't know. Okay, so that's it for today. So thanks a lot for watching, and on the tube testing side, I will discuss this with the owner and let him decide what he wants me to do. Okay, very good. And gee, something new got to be on my bench. Wonder what that might be. How about another tube tester? Yeah, that might be good. See you later. Enjoy your day. Bye-bye.